Hey guys, welcome back. In this video, I'm going to work out question 10 part A of the CXC CSEC Math January 2012 paper 2. 10A tells us that the diagram below, not drawn to scale, shows a regular hexagon with center O and AO being equal to 5 centimeters. So this is the hexagon and this is AO and it's 5 centimeters. Part 1, we want to determine the size of angle AOB, and part 2, we want to calculate to the nearest whole number the area of the hexagon. Okay, now since this hexagon is regular, it would follow that these triangles that we're seeing here are all congruent to each other. There are 6 of them in all. Now, them being congruent means that corresponding angles have equal size, and in particular, this angle here, which is the angle we want to calculate, AOB, has the same size as this angle here, which has the same size as this angle here, which has the same size as this angle here, and this angle here, and this angle here. Now the sum of these angles is 360 degrees. So it means then that 6 times angle AOB is equal to 360 degrees. And so it means angle AOB is equal to 360 degrees divided by 6, which is equal to 60 degrees. So the size of angle AOB is 60 degrees. Part 2 tells us to calculate to the nearest whole number the area of the hexagon. Now the area of the hexagon is the sum of the areas of the triangles. Since the triangles are congruent, that means the triangles have the same area. So if we can calculate the area of one of these triangles, then we can calculate the area of the hexagon by multiplying the area of the triangle by 6. So what is the area of the triangle and what formula do we use? Let me clear the screen. Now, if this is 5 centimeters, this is 5 centimeters. And we already know the angle here is 60 degrees. Now we have a formula for the area of a triangle which tells us that the area of the triangle is a half times AB sine C. So A and B are two legs of the triangle, and C is the angle between those two legs. So in our case, we can put A as this as the length of this side and B as the length of this side, and this here would be our C. Right, so this is a leg of the triangle, this is a leg of the triangle, and this is the size of the included angle. So it means then that the area of triangle AOB is equal to a half times 5 times 5 times sine of 60 degrees, which is equal to 25 over 2 times sine 60 degrees is square root of 3 over 2. So this is 25 square root 3 divided by 4. And so the area of the hexagon is 6 times the area of triangle AOB, which is 6. So area of hexagon is equal to 6 times 25 square root 3 over 4. 2 into 4, 2. 2 into 6, 3. 3 times 25 is 75, so you get 75 square root 3 over 2. Now, I left the square root 3 in here, and I left it as a fraction, so as not to approximate too early. If we approximate too early, then the final approximation that we do might be off by more than it really needs to be. So we leave it in this form, which is an exact form, and we do the final approximation at the end. So calculating what this is, that is equal to 64.951905, etc. And we want to approximate this to the nearest whole number. Well, 64.951905 is closer to 65 than to 64. So to the nearest whole number, this is equal to 65 centimeters squared. And that's it.